let's look at how we can calculate the probability or the likelihood of a particular event happen. We are just going to be looking at one independent event. So independent doesn't matter here because there's not two events, but we're looking at one event. Okay, so we've got red, blue, and green. These are inside of our jars, and they're marbles inside the jar. Okay, so let's take the first one. What is the probability that we're going to get a red marble? If we reach our hand in and grab any marble at random, well, I've only got one inside out of, well, how many marbles do I have? 1, 2, 3. So I have a 1 in 3 chance of grabbing a red marble if I put my hand in. Okay, now how about blue? Well, if all the marbles are in the jar and I reach my hand in, what's the probability I'll pull out a blue? Well, it's the same, isn't it? Because there's only one. And the same for green. If all the marbles are in the jar and I reach my hand in, the probability of me choosing a green is going to be 1 out of 3 because there's only one in the jar. Now let's add these up. So let's just pretend there's a plus sign here. Remember, when we add fractions, our denominator, we're going to keep it the same. And we're going to go 1, 2, 3, count the numerators. Okay, so the sum of those probabilities equals 1. All right, let's go to the next one. Okay, I'm going to reach my hand in the jar. I'm not going to look, swirled around. How many reds? 1, 2. How many marbles altogether? Well, this time there's 5. Okay, let's look at blue. Again, I'm going to reach my hand in, swirled around without looking, and I have 2 blue marbles in this jar out of 5 still. And green. I'm going to reach my hand in, but I only have a 1 in 5 chance of grabbing a green one because there's only one green marble. Okay, so like last time, let's add these up. Forgot an equal sign over here. Okay, again, we've got common denominator. We're going to leave that alone. We're going to count the top 2, 4, 5. Interesting. It also equals 1. Okay, let's go to our next jar. It's bigger. It's got more marbles. What's the chance I'm going to grab a red? Well, let's count. 1, 2, 3, 4. How many marbles altogether? Well, there's 4 reds, 5, 6, 7, 8, 9. How about a blue? 1, 2, 3 blues out of 9 marbles. How many green? Well, there's only 2. So I have a 2 in 9 chance. Just like last time, let's add these up. Okay, keep 9 as our denominator. 4, 7, 8, 9. That's interesting. That's also equal to 1. Okay, last jar. This time I've got 1, 2, 3, 4, 5. How many marbles altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now we know there's going to be 12 in every jar, so we don't have to count that again, thankfully. How many blues? 1, 2, 3, and still only 12. And green, 1, 2, 3, 4 out of 12. Okay, last one, let's add them up. 5, 8, 12. Which is also 1. Okay, so a few things for us to observe here is that the top number in our probability is how many of the item we're interested in. So when I'm talking about the probability of red, I want to count up how many red ones. Okay, and the bottom number is always going to be the total number of possible outcomes that could happen. So if I reach in, there's 3 marbles I could potentially grab. So I would put 3 on the bottom. Okay, and the same thing with all of these fractions. The top number represents how many of the item I'm interested, and the bottom tells me how many items in total that I could potentially select or that could potentially happen. All right, something important about probability is it's called probability notation. Okay, and it has a P with an open parenthesis, and inside the parenthesis, we put the thing that we're trying to find the probability of. So in this case, the probability of getting a red. And we would follow that by an equal sign. So for example, here we would put P red and then equals 1/3. So for this first scenario. For this next one, let's see, what are we going to put inside? Well, we're looking at the probability of grabbing a blue marble. So I'm going to write the word blue. Close off my parentheses and put an equal sign. And the last one here, I'm considering a green. So my probability notation would be green equals, and then we would put the fraction representing the probability of selecting the green in each of these different scenarios. All right, so just to clarify, these are all different probability events that we're talking about that we have in our table. Okay, now the reason we don't just put P is because P represents perimeter when we're talking about shapes. So P cannot represent probability. So that's why it's really important when we do probability, we have a P with an open bracket, and then we specify the thing inside that we're trying to find the probability of. Okay, now let's write ourselves our formula. So the probability of an event, any event that we're talking about, this is where the red, blue, and green go, right? But we want to have something general. So the probability of any event happening equals, so the number of outcomes for that event. Okay, so in our case, the number of red marbles, the number of blue marbles, the number of green marbles, and on the bottom we put total number of possible outcomes. Oops. Okay, so there's the formula that you're probably going to see in a textbook that we're going to use, and that's all that it means. We're going to look at some examples. All right, let's do a few examples you might see in your book. We're going to keep our formula, okay, and we're going to practice probability notation and then finding that fraction. So we have a die that has 6 sides. This is a regular playing die. It has a number on from 1 to 6 on each side. What is the probability of rolling a 5? Well, our probability notation, remember P, open bracket, we're going to put the number that we're interested in, which is a 5, equals. Well, how many 5s are on a dice? There's 1. How many sides does the dice have? 6. So there's our answer, 1 over 6. What is the probability of rolling an even number? Okay, so probability notation, we're going to put the word even inside, equals how many even numbers? Well, if they go from 1 to 6, my even numbers are going to be 2, 4, and 6. So there's 3 possible outcomes that could happen out of 6 sides of the dice. Now this fraction can be reduced. We can divide it by 3, right? So I like to do this notation, but you might have seen it differently. 3 divided by 3 is 1. 6 divided by 3 is 2. So our answer would be 1/2 as a reduced fraction. Okay, 3/6 is correct, but 1/2 is reduced. Last one with our dice. What is the probability of rolling a number less than or equal to 2? Okay, so I could roll a 1 or a 2, but no other numbers are less than or equal to 2. So let's write our probability notation. P, I'm going to put less than or equal to 2. We want to keep it short and sweet inside there. And we decided there was 2 numbers that satisfy that criteria, and there's still 6 sides on my die. I can reduce this. It's even, so I can divide both sides by 2, or the top and the bottom, sorry. 2 divided by 2 equals 1. 6 divided by 2 is 3. So my answer is 1/3. Okay, our last example is a spinner. What is the probability of the spinner landing on a 3? Well, how many 3s are there? Let's do our probability notation first. There's 1 3 on the spinner. And how many sections could it possibly be? There's 8. So our answer is 3/8, and that cannot be reduced. What is the probability of the spinner landing on an odd number? So let's do our probability notation. Odd equals, how many odd numbers are there? 1, 3, 5, and 7. So I've got 4 odd numbers, and I still have 8 numbers in total, and that can definitely be reduced, 4 and 8. Let's divide those by 4. 4 divided by 4 equals 1. 8 divided by 4 is 2. So my answer is 1/2. And my last one, what's the probability that it was going to land on a red section? So I'm going to put P of red equals, and how many red sections? There's 2, and my spinner still has 8 sections. That can be reduced by 2 because they're both even. 2 divided by 2 is 1. 8 divided by 2 is 4.